In the last video, I showed you the Tutris SK1 3D printer. One big bet was the old firmware version of this 3D printer. Today, I'm going to show you how to update that firmware to a more civilized version. Everything you will see in this video is done by a person who has some idea of what he is doing. Everything you do is at your own risk. In this video, I will show you a simpler but from the user's point of view sufficient update of the printer. During the wall update, you will need to have the printer connected to the internet via a network cable. Before we begin, be sure to back up anything you don't want to lose. We will update the printer based on the original system version, which is available on the manufacturer's wiki at the bottom of the page. If you do not have this version installed on your printer, please use the following instructions to load it into your printer. To do this, you will need to download this file, which contains the entire Linux system of your printer. While downloading, unplug the eMMC memory from the printer while it is turned off and connect it to your computer using the eMMC reader. Extract the downloaded file to disk. Transfer the disk image to eMMC memory using, for example, the Balena Etch software. To do this, simply select the unzipped file, choose the connected eMMC memory as the destination and start the transfer. Once the new operating system has been transferred to the eMMC memory, simply disconnect the disk from the computer and return it to the printer. Once powered on, the printer should boot up as if it had just been unpacked from the box. Now, let's update the touchscreen firmware. This update can be done even when the printer is powered on. Thanks to the display, we get easy access to the IP address of the printer. On the Google Drive website, go one level back and download the TFT file from the second folder. Download this file to the memory card that came with the printer and name it lks.tft. Carefully remove the display from the printer and disconnect it from the data cable. Unscrew the back cover of the display and insert the memory card into the slot. Plug the disassembled display back into the data cable and wait until the display shows you that the update has finished. Then remove the memory card and disconnect the display from the data cable. The display is now updated and you can put it back together in its original form. When you connect it to the data cable, it should turn on as if nothing has just happened. The next step is to perform the update on the Linux computer side of the printer. The IP address of the printer needed for work can be found using the display in the case of connection via LAN cable or Wi-Fi. Log in to the printer via SSH using the printer IP address, the login name MKS and the password MakerBase. If you see this prompt, confirm it. To make things easier for you, I have prepared a list of commands that you can run in small blocks. You can find a link to this file in the video description. With these commands, we first gain root privileges. Then we update the Linux packages. Then we stop all the services that we are going to update. We will remove any changes in the Clipper folder, update to the latest version, and return to the previous folder. We will do the same in the Moonraker folder and again return to the parent folder. We will create a new folder structure and copy the necessary printer files into them. Delete the old folders and files. To get the display working, we need to link the printer configuration file to the original folder. In this file, we then override the old values and add the code that will automatically load the default print bed calibration profile when the printer is started. This is important for the printer's display calibration function. We will also add support for adaptive print bed calibration, which we will talk about later. In the next step, we will update the Moonraker configuration. Then we will override the old folder locations in the user script. We will do the same in the root script. We will also need to change these locations in the printer's system services. After these changes, the most important thing is updated and the changed services need to be reloaded. To make the webcam work better, we stop and disable the service the printer is currently using and install another one. This service needs to be installed in an older version, as we will not be updating the printer system in this video. Once installed, we will set a different path to the camera and restart all services. Then we run the Kiao and confirm the update. This is a helper for installing and updating Klipper and its components. After the update, run it again, and now you need to decide whether you want to use the Fluid or Mindsail web interface. Basically, it doesn't matter which interface you choose. The important thing is to delete the old version of the Fluid interface first and then install the new one. After deleting the old version of Fluid, you need to go back to the previous menu and install the new interface. I decided to go with the Mindsail interface. It is also important not to install sample configuration files during installation. Otherwise, the display would stop working and the printer would not behave as it should. Once the installation is complete, it is time to reboot the printer for the first time. After each printer reboot, you will need to log in to the printer again using SSH. After updating the Linux computer, it's time to update the motherboard. Before proceeding, you need to plug the card reader into the printer with the memory card that came with the printer. The card should load as folder SDA1 in the web interface in the print files. To make your life easier, I have prepared a command for this action as well. If you see a different name in your browser, change it in the command as well. When you run the command, a configuration window will open. In this window, set everything according to what you see on the screen right now. When you have finished making changes, press the letter Q on your keyboard and confirm saving your changes with Y. Once the firmware has been compiled and copied to the attached memory card, you should see the OK.gcode file appear in the web interface. You can delete this file. Disconnect the card reader, and when the memory card folder disappears from the interface, turn off the printer. Insert the memory card into the motherboard, but do not turn on the printer yet. Without updating the printhead, your printer will not work. Therefore, let's update the printhead firmware. This is where things get a little complicated. To make it easier to work with the printhead, I also disconnected the PTFE tube. This is not necessary, however. First, we need to access the printhead motherboard, which is hidden under this cover. This is blocked by the power chain arm. To remove the cover, you have to unscrew the two screws on each side of the cover that holds this cover on. Now, loosen the data cable and disconnect it from the motherboard. Then remove the 4 screws that hold the motherboard on the printhead. Notice the connector labeled download, which is actually just a USB connector. It can be used to upload firmware to the motherboard. Note the colors on the wires and on the motherboard. But be careful. Some USB cables may have wires with different colors. Avoid such cables in order to avoid damaging the motherboard or the computer to which the motherboard will eventually be connected. A simple voltmeter should help you check the correct polarity of the power wires. For the possibility of easier future updates of the printhead firmware, I decided to use DuPont connectors. However, nothing stops you from using older connectors. After soldering the connector to the motherboard, attach it back to the printhead. Without the data cable plugged in, turn the printer on. Then plug the USB connector into the motherboard, hold down the boot button, plug the USB connector into the printer and release the button. The printhead uses a Raspberry Pi RP2040 microcontroller. In January 2024, code was added to the Klipper repository telling the RP2040 to use more of its RAM. On some RP24s, an error will occur when running the firmware and the microcontroller will stop communicating. Unfortunately, this happens with my printhead as well. I have prepared 2 commands to help you build the firmware and upload it to the printhead. The first command is to build the latest version of Klipper. The second command is to build an older version of Klipper. When you run either command, a configuration window will open. In this window, set up everything according to what you see on the screen now. When you have finished making changes, press the letter Q on your keyboard and confirm saving your changes with Y. Once the firmware has been compiled, it will be uploaded to the microcontroller. The microcontroller will reboot itself after a firmware update. Then disconnect the USB cable and turn the printer off. Plug the data cable back in and turn the printer on. The printer should boot up fine. If this does not happen, the reason will probably be the strangely behaving RP24. Disconnect the data cable to avoid damage to the printer computer. Plug the USB cable into the connector as before. Then hold down the boot button on the printhead motherboard and plug the USB connector into the printer. Run this second command and again set everything as you now see on the screen. When you have finished making changes, press the letter Q on your keyboard and confirm saving your changes with Y. Once the firmware has been compiled, it will be uploaded to the microcontroller. The microcontroller will reboot itself after a firmware update. Then disconnect the USB cable and turn the printer off. Plug the data cable back in and turn the printer on. The printer should boot up fine. If not, try repeating the entire update process or uploading the original firmware from the manufacturer's website. The new firmware also brings new features. One very welcome feature is the calibration of the print bed in the print area only. To make this feature work properly, we have already made changes to the printer configuration during the firmware update. For this feature to work properly, you need to have print object labeling enabled in the slicer. Cura already has this labeling turned on automatically. If you want to use your USB camera for pre-monitoring, plug it into a USB and add the camera in the web interface. Just a few clicks in the menu and the camera should show up immediately. If the camera doesn't show up, you can look in the crownest.log file and look for the latest occurrence of the text "Detect available devices." Copy and paste the long or short path of the camera into the crownest.conf file. For the main cell interface, just open the crownest.conf file and click this button. Update the list of video devices and copy the long or short path of the camera. After making all the necessary changes, save the file. The camera should now be working. Finally, all that is left is to calibrate the printer using the display. Once all the calibrations are done, you can send some test prints to the printer. The printer should calibrate the print bed in the print area only. If everything works as it should, you can congratulate yourself and have a shot of something to drink for a job well done. If the printer doesn't work, please don't be mad at me. I did warn you at the beginning of the video.